Hi students, let's look at this question here, which is on finding the gradient of the curve. This concept here about the derivative as a gradient function. So let's see how we can understand this properly. So you're told to find the gradient of this curve here when x is equal to 2. Okay, so you already know how to find the derivative, right? So in this case here, what I'll suggest is essentially just, now this is the curve which is x minus 1, 2x plus 3. We know that when x is 0, so this a when this is 0, okay, when is at when it's horizontal here, okay, the gradient is 0, right? But because this iteration I can't really get in the middle, but what you need to understand is actually as you increase, you want to find when x equals to 2 what is the gradient here. So when x equals to 2, so like that, for example, like that. Okay, so what is this gradient here? Now remember that actually this is my gradient value here. So when a is 2, this is my gradient. Okay, so how do you actually find this gradient value here? We're going to use the gradient function. Okay, so the gradient function, this is what's happening. What we need to do is actually just find dy dx and just sub x 2 inside. Now this is a boundary condition, so you don't sub it at the start, you only sub it at the very end. Okay, because y and x, they are actually changing, and x and y, they are variables, so there's no fixed value at the start. So what we're going to do is actually we're just going to expand this. I think the easiest is expand this to, you could use product rule obviously, but I'm going to expand this first. So 2x squared plus 3x minus 2x minus 3, so this will be y equals to 2x squared plus x minus 3. So dy dx would just be 4x plus 1. Okay, so if when x equals to 2, gradient of the curve will be dy dx when x equals to 2. So sometimes you can write it as such, meaning you sub 2 inside, so this is 4 times 2 plus 1, so this is actually 9. So that's how we get the value 9 here. As you can see that this is 9, the gradient here is 9. Okay, so it's upward sloping, so it's correct. So that's how you do this question here proficiently. This is very important concept. Okay, so just make sure that you understand this part, and yeah, I'll see you in the next question.